Hi guys, I hope you are all doing well. Let's see today's question. So today's question, we are taking this up from the topic of sequence and series. And particularly if I talk about the question, it is from the concept of infinite geometric progression. So question tells us let AR square, and so on be your infinite geometric progression. And then they have given us two conditions which says summation of n equals 0 to infinity a r raised to n is equals to 57, and the other conditions as summation of n equals to 0 to infinity a cube and r raised to 3n is equals to 9747. Then the question is asking us to figure out the value of this a+18r. And if I talk about the answer choices that we have here, the options are 27, 38. Then we have our next option as 31, and the last answer choice given to us is 46. So we need to figure out which one of the answer choices is the correct answer for this question that is asked to us. When they have asked us to find a+18r, I understand I need to find a, I need to find r. And once I get both of them, I'll just put it in this equation and get the answer for the question, right? So let's try to solve this further. Before starting with the solution, I would first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos for you. And it also motivates me to put up better content and try to make the solutions as easy as possible so you understand them in a better way. Let's see how to solve this question further. So what I understand from this thing is we know it's an infinite geometric progression. And when I have an infinite geometric progression and my list, when it is AR square, and so on, I understand that infinite geometric progression has the sum of n terms given as a over 1 minus r, or some of the infinite terms that you have, it's given as a over 1 minus r, not n terms, because there are infinite terms that you are adding up. So that is given by a over 1 minus r, and we also know that r is always less than 1. So that common ratio which you are multiplying with the previous term to get the next term will always become less than 1. So if I use my ideas that are given to me, it says summation of n equals to 0 to infinity a r raised to n is equals to 57. So summation of n equals to 0 to infinity a r raised to n is equals to 57. So if I substitute, let's say n as 0 first, I get r raised to 0, which is 1. So a plus ar square, and so on till infinite terms, the sum of that is 57. So if I use my idea, sum of infinite terms, the first term is a divided by 1 minus r is equals to 57. So I know this equation 1 because I'm multiplying each term with r to get my next term. So I have one equation with me. Second equation, if I try to figure out, it says summation of n equals 0 to infinity a cube and r raised to 3n is equals to 9747. So if I use this also, I get n equals to 0 if I put, I get a cube. N equals to 1 if I put, I get a cube r cube. If I put n equals to 2, I get a cube r raised to 6, and so on. The sum of this infinite terms is also 9747. Now if I use my idea again, sum of infinite terms of this geometric progression is given by a cube divided by, and I am having 1 minus r. R in this case is the common ratio. And to get my next term, I'm multiplying my each term with not r, we are multiplying with r cube. So here instead of r, you will have r cube, and that's equals to 9747. So I have this, I have both of my equations. One is a over 1 minus r is 57, and the second says a cube over 1 minus r cube is 9747. Once I have both of them, let's try to make it same so that one of the variable gets cancelled, because this is the equation, two equations with two variables. So I'll cube this. Let's cube it. So I get this as a cube, 1 minus r the whole cube, and this is 57 the whole cube. So let's say this is my equation 3. And this equation as I have as it is a cube over 1 minus r cube, which is 9747, which is basically my second equation. So if I divide both of them, let's actually divide both of them. So if I'm dividing, let's say 3 with 2, what I get here is a cube over 1 minus r the whole cube, the whole thing divided by a cube divided by 1 minus r cube. So this and this gets cancelled. I get 57 cubed. So 57 is basically multiplied 3 times, and this 9747 is also divided with it. Now, if I try to reduce this, let's try to do that. So 3 times 19. If I try to cancel this with 3, 3 threes is 9, 3 twos is 6, so 14, 3 fours is 12, so 27, 3 nines is 27, 3 19, 3 ones is 3, 0, 3 eights is 24, and 3 threes is 9. Again 19, 3 threes is 9, 18, 3 sixes is 18, and 3 ones is 3. So 19 ones and 19 squared is 361. So I can cancel two 19s directly. So I'm just left with 19. So I get from here, and this, if I see, this is present in the denominator of a denominator. So it basically goes in the numerator. So 1 minus r cube divided by 1 minus r the whole cube is equals to 19. So if I split this and solve this further, I get 1 minus r, because I can write this as a cube minus b cube. So 1 minus r, and I get 1 plus r squared divided by 1 minus r the whole cube is equals to 19. So this gets cancelled, and here I have only two terms left. So I get 1 plus r square is equals to 19, and 1 minus r the whole square gives you 1 minus 2r plus r square. So from here I get 1 plus r square equals 19 minus 38r plus 19r square. If I solve all of them together, let's take everything together here. So his 0 is equals to, I'm taking everything on the right hand side. So 19r square plus r square, if it goes there, becomes minus r square. So 18r square minus 38r, and this also comes here. So becomes minus 39r, and plus 19 and plus 1 goes there, becomes minus 1. So 18 equals 0. So I get this equation as 18r square minus 39r plus 18 equals to 0. So I have to find my two numbers whose product is 18 into 18, whatever it comes, and the sum of that should become minus 39. So if I try to get 18 into 18, first I can just take the two numbers as 18, but 18 plus 18 is 36. So that does not work. If I take 18, I split, let's say this 18, I get, this is 9 into 2. So if I multiply 18 with 2, I get 36 and 9. 36 and 9 also doesn't work because it's 45. Now what I can do is I can split that 9 also. So 3 into 3 into 2 here, and 3 into 3 into 2 here. So let's say if I multiply these two threes with this 3, so 3 threes, so 27, and 3 twos is 6 and 12. So yeah, that works. So minus 27 and minus 12 also gives me minus 39. So I split this basically as 18r square minus 27r minus 12r plus 18 equals to 0. So I get from here, if I see four terms, I take common from the first two and from the next two. And what I get from here is 18 and 27. So I can take 9 common, r common. So I'm left with 2r minus 3. Minus from 12 and 18 also I can take 6 common. So I have 2r minus 3 equals 0. So I get 9r minus 6. I get 2r minus 3 equals 0. So 9r minus 6 equals 0, or 2r minus 3 equals 0. So you get 9r is equals to 6, or r is equals to 6 over 9, which is 2 over 3. Here you get 2r equals 3, so r is 3 over 2. So I have two values of r. That's basically my common ratio. Either r is 2/3 or 3 over 2. So 3 over 2, if you see, it's basically 1.5, which is greater than 1, and this value of r is rejected. So I have only one value of r, and that is 2 over 3. So I get r as 2 over 3, and that gives me the value of r. If I use that idea to get me the value of A now, I have my first equation as A over 1 minus R was 57, right? So A over 1 minus R, when it becomes 57, I get A as 57 times 1 minus R, and that gives me 57 times 1 minus R. In this case is 2/3. So it basically becomes 2/3. So 1 minus 2/3 is 1/3. And 57 into 1/3, I get this is 19. So I get A as 19, I get R as 2/3. Now, if I use this idea to get the answer to the question that's asking us, A plus 18R. So A, I got this as 19. And 18 times R in this case, I got that as 2/3. So 3 ones and 3 6. So 19 plus 12, which is 31. So I get the answer to the question, and that basically matches with answer choice C. So C becomes the correct answer for the question that is given to us here. I hope you have understood how to solve this type of questions, which deals with the concepts of geometric progression and usage of this formula of infinite geometric progression. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains from the current year 2024 of April. So if you are enjoying these videos, please do like the videos and comment on the videos and share this with your friends also who are involved in the preparation of the questions on this JEE. So I'll see you again tomorrow. Thank you.